vLLM nowadays become synonymous with inference and inference runtime. I've been reading all the news about data center build out and new capacity being added. The way I'm reading it is all of those will become inference compute. The cluster are being built for training, but 6 months later, the cluster will be used entirely for inference. We're seeing the paradigm shift from building vertical system. For example, OpenAI, there's inference engine for Sora. There's another inference engine for new version of Sora. We're building one inference engine for all the current and future model, for all the current and future hardware, and for all the current and future applications. Our end users are all users of vLLM. So that means regardless of anyone, as long as they are using vLLM, deploying vLLM, and need our help within their services and within their hardware, within their model, we are there to serve them and want to help them to make them successful so that we can all together make vLLM the best inference engine in the world.
Hi, everyone. I'm Bucky Moore, partner at Lightspeed.
And I'm James Alcorn, also a partner at Lightspeed.
And this is the Investment Memo, the show where founders reveal the stories behind their businesses and how they will shape the future of their industries. Today, we're joined by Simon Moe, CEO and co-founder of Inferact, the company making fast and efficient AI possible with a high-performance inference engine called vLLM. Simon co-created vLLM as an open source project at UC Berkeley just over 2 years ago. It's already become one of the most widely supported AI infrastructure projects to date. Major cloud providers and leading model labs use vLLM in their products, and Inferact is going to deploy it at an even larger scale.
As a partner investing in AI and infrastructure, I co-led Lightspeed's Inferact investment alongside Bucky. And I'm privileged to have known Simon for a few years before the company got off the ground. So I'm really excited to share this story with you, and today we'll talk about how inference became one of the most valuable layers in the AI stack, how Simon grew such an active developer community around vLLM, and Inferact's plans for the future of enterprise AI. So, Simon, welcome to the show.
James, Bucky, thank you for having me.
So congrats on the funding announcement today. What I thought we could do is share this investment memo with you, which is actually internal to Lightspeed. Have you ever seen one of these before?
No, first time seeing an investment memo.
Let's take a look. So at the core of every investment is a thesis, and we wanted to walk through ours with you. So what you see here is the first point is this view that we have that inference will capture disproportionate value in the AI stack. It's increasingly the choke point where all model execution, optimization, and data flows converge. vLLM is obviously at the center of this. And so could you bring us back to the moment before you started vLLM with your co-founders and what insight did you have that led you to start the project?
First of all, thank you for having me. Going back a little bit, my experience with open source project and working with Ian Stoica, Joseph Gonzalez, and overall at UC Berkeley has been the history of open source model serving. At that point, we don't even call this inference, but rather it's called model serving for machine learning models. So that's around circa 2017, 2018. And then after that, we enter into the phase of accelerated computing for prediction models. And around 2023, while I was at Berkeley, I met Usuk, I met Johan, who are the initial creators of vLLM as an academic project. So at the early days of 2023, they were building a demo around, at that point, a model called OPT-175B from Meta. And that was kind of a replication, open replication of GPT-3. And at that point, they found it very, very difficult to serve that model that big efficiently on accelerated computing devices. And over time, this experience built up. They started to find out different scheduling algorithm, memory management algorithm, and build up an academic paper around it. Interestingly, that was during one of my first spring break as a PhD, so I get to involve a little bit with the project, but I was like, I'm gonna explore something else. So actually, that's my first interaction with vLLM was a miss. Actually ended up joining the academic paper, but very quickly I joined the open source project where we turn a academic prototype experimental testbed into a fully functional end-to-end system where anybody can contribute to and install and run. And we kind of hit the ground running around the summer and fall of 2023. And the story ever since is then become this kind of industry standard layer for inference where models meets hardware. And when workloads are able to use this open source inference layer to be able to actually run it at maximally efficient speed, and folks are deploying it across the industry.
And we talk a lot about speed when it comes to inference. Tell us a little bit more about what it means to push the field forward. Is it speed? Is it throughput? Is it efficiency? How do all these things come together?
So in the end, it's about getting the best out of the hardware at hand right now. So this is the most expensive part of AI right now. The chip itself just cost a significant amount of capital to procure. But then if you think about the whole process, in order to produce these models, we have to build the data centers and then build the training cluster. And then from the training cluster, you produce a model. But at that point, there's no value created. Only delivering intelligence and delivering inference is a point where you can actually leverage and capitalize and be able to get benefit of this intelligence. And then the requirement pretty much stem from that. You want maximum efficiency. But on top of maximum efficiency, it could mean maximum throughput. That means processing as many records and as many conversations concurrently as possible. But also, it could mean latency. It means it could be syncing, having a long conversation, multi-turn conversation, syncing traces, solving a very hard problem, and turning from what would take 8 hours of human labors into an hour of AI labors to a minute of very fast interaction with the external environment. So speed matters, throughput matters. In the end, cost is a fundamental factor we're optimizing against.
And this notion of paged attention, like why start with this? And talk to us a little bit about like how this came to be and the opportunities it unlocks.
So the core technique of page attention actually goes back to figuring out the transition from a batch synchronous, what we call micro-batching serving, to a continuous language modeling kind of serving paradigm. So before 2022, I was working on prediction serving in terms of micro-batching. That was when we're serving regression models, serving recommendation models, serving and image vision understanding model. What you do there, input is uniform. Everybody has similar images, similar size. Output is uniform. It's all the same structure of prediction. So it's very easy to manage. You take a batch and then you process it, return it. But for language model, input is non-deterministic because it comes from user. It could be a single word, hello. It could be a paragraph of a request. It could be several documents combined together. It could be even just a whole book or a thesis for folks to digest, for the model to digest. But then the output is also non-deterministic. It could be, again, one word to thousands of words to maximizing the entire context window. So with this kind of non-determinism and non-uniformity, you actually need to have a better way to schedule the request and manage the state associated with the request. And that's why page attention was born. And page attention is one of the core techniques within vLLM to manage this disparity and be able to maximize throughput of the whole system while maintaining the state, maintaining the utilization, and be able to deal with this kind of different kinds of requests having different lens problem.
What is the future implementation of the attention, approach a year from now? Like, how does it change?
So attention has actually evolved quite a bit, even though everybody's saying, oh, transformer hasn't changed since Noam and team kind of invented it. But actually, attention has been changing every 6 months. So in the beginning, we have what we call multi-headed attention. And then later, the evolution to make it more efficient has already gone underway in 2023 and 2024. That's when we have what we call group query attention and multi-query attention. So that actually become a lot more efficient already. And in vLLM, we dealt with this variant from day one. But then afterwards, there is attention introduced, I think, in the first version of open source model that will be introduced by Mistral called sliding window attention, which of course goes back years in the literature of academic work that will compress and only use part of the context window for the next prediction. And then, of course, nowadays, if you look at it, DeepSeek has MLA, Kimi has different version, and then Qwen models and GPTOS says everybody's attention is a big variant from the original intention. And then looking forward, we're seeing linear attention and different kinds of hybrid, even quadratic attention and super quadratic attention coming up. So it's a rich field of innovation. Page attention is just one small core technique. vLLM today is encompassing tens and even more different kinds of attention variant and implementation. And
a lot of that, I guess, has come from the amazing community you've built around the open source project. I wonder if you could take us back a little bit and tell us about, the inception of the open source project and, the enormous growth that it's seen since. Like, what did you do to catalyze that?
So a lot of it were, I would say, we're fortunate and lucky to have that community and to grow with it. And in the beginning, what we have is an open source project with just passionate adopter, contributor. People actually see value in it. In the beginning, vLLM was used as a replacement for Hugging Face Transformers pipeline, which was a different paradigm of running inference because it was really used for training system, not inference system. Then over time, we're seeing folks kind of come around and start to center around the vLLM community. So we start have companies who are building models, are actively working with us, say, in contributing and maintaining their model implementation as well as techniques. Hardware companies were able to start optimizing for specific models and across the entire variant within vLLM, adding new kernels, adding new supports. And then finally, application companies who are deploying vLLM either for their customers or for directly for the end applications now start to add all kinds of optimization they believe essential or useful. And everybody wants is the same thing, to contribute what they have into the open platform and ecosystem so others can benefit and they can also benefit from others' contribution as well. And we ended up leading the project from UC Berkeley as graduate students to land this entire community and grow with it. We have in-person meetup every 2 months, and that's where we kind of see the community face-to-face, but also there's also global community nowadays across the world where different kind of organizations are leading to be able to build this presence together.
Yeah, I'm glad you brought up hardware because it's such an incredibly important user constituency for the project. So maybe you could tell us about how you've engaged the hardware vendors and what your kind of strategy and relationship there has been.
Yeah, this has definitely been evolving as well. One thing that doesn't change is we want to keep this extremely open-minded. So that means we are very much receptive and open to new hardware variants. The reason is openness brings innovations and people building on top of each other's work, as well as be able to differentiate and based off different workload and be able to understand pros and cons of different chips. So when we work with hardware vendors, the format and interaction model are quite different, right? For example, for currently the market leader, NVIDIA has a dedicated team right now working on vLLM that focus across different generation of chips, as well as chips are not released yet, as well as a software layer thinking about how do the entire CUDA ecosystem integrate with vLLM and together. And AMD have similar thing. For example, AMD have a dedicated team not just working on vLLM, but also sponsoring and supporting the CI system. So AMD has been hard at work pushing, making sure every single test in vLLM, when it passes on NVIDIA chips, it passes on AMD chips, so that the users of vLLM can seamlessly switch between. And of course, you could say this is quite a good strategy from the AMD side, and we're happy to work with the entire ecosystem to bring that together. And these are just two examples. We'll work with TPU, AWS Neuron, Intel, and so much more.
And when did it become clear to you that vLLM was the de facto standard the way we perceive it to be today?
When a new model vendor start to talk to us, it's like, hey, we want to release a new model, and vLLM is our first and sometimes even only place to go, that we want to make sure that the world can use our model. There's other ways they can release a model to the world, but they have this collective understanding and consensus from the model side that vLLM is where they should do it, and they should build a relationship to build it out for. And likewise for hardware, if you're making a new chip today, and after you finish the design tape out, have all the understanding of the chip, when you need to build a software stack, not just as a chip provider, you want to talk to vLLM. What I'm hearing is the customer, the prospective customer of the new chip and accelerator are asking, can you please add vLLM support? vLLM nowadays become synonymous with inference and inference runtime, so that I'm hearing everybody is asking about vLLM support equal to the way I'm going to interact with this model is going to be through vLLM. And that's kind of the moment.
So Simon, we originally met at the Sky Lab in Berkeley and spent many hours walking around that beautiful campus. At what point did you know that you wanted to start a company?
Yeah, go Bears. I wasn't thinking about starting a company when we very first met, but over time, we're constantly reevaluating and thinking about this. It's actually not an easy decision. James would have known. This has been I would say, two years in the making. So every time we are assessing the current state of vLLM, the current state of ourselves as co-founding team, how we're approaching this, as well as the market. So I would say it is only until around this time we have decided the market is right, the stack is right, vLLM is at the right time. It also necessitates us to have this company to be able to push it to the next step and further. And this really draws on my experience last year, spending some time at Character AI, running the inference stack, and understanding really real-world inference at scale, right? As much as I know about vLLM, there's actually so much more you need to build around to constitute as an inference platform. And additionally, for the things you build around it, you can actually integrate with vLLM really well to deliver the 2x, 3x, and even more efficiency gain that you can unlock. And you just cannot unlock it with vLLM as a standalone open source software. So that's the sort of one of the primary realization. And this realization really echoes among the co-founder working at different places, adopting vLLM, using vLLM, pushing vLLM at scale, that help us really understand and come to the consensus. The timing is right, the market is right, there is so much to build, and it is time to build that.
Which set of cultural values did you and your co-founders, or do you and your co-founders want, Inferact to really be defined by?
The cultural values were really aspiring to start with openness. Open source is at the forefront and what we care about. And we truly believe open source model, open source implementation, open source runtime system is the fastest ways to bring innovation and to progress. So as everyone working at Inferact right now, we have the attitude of being open-minded. But of course, open-minded doesn't mean accepting everything. There's a clear line we're walking here. That's why the second culture value is also to be opinionated, to understand the future by understanding the history, understanding the data. So this is where we want to hear as many things as possible, perceiving as many data points as possible. But then the open source value is also about really making big bets of the future, build it out together, and then aligning the entire community to go with us.
What do you consider most when you built the initial team? Like you had this group of co-founders that you were working on the project with. I know you're doing a lot of hiring right now. But to James's question about culture, like how is that manifesting in terms of the people that you're bringing together to build this company with you?
We are looking for intellectually deep, right? And people who have this sense of humility, being humble to be able to work together. And this is where I see in Woo-Suk, seeing Kai-Chao, seeing as well as Roger, that we have this team where everybody is extremely humble, extremely intelligent, but also have this ability to work together to really work on ambitious, hard problem. Inference, after all, is a very, very hard problem to solve. So we're building this team together and realizing that in order to solve the hard problem, you need a team of folks who understand everything inside out, be a little bit opinionated, but also be nice to each other, be able to figure out we're all in this for the technically deep problem that's decades to come.
So AI is evolving at breakneck speed. How are you making sense of that? And how are you keeping pace with it in the context of the way you're designing the company?
AI is changing indeed, and inference is changing drastically. From my point of view, the only competition that we have is vertically integrated, specialized inference engine that is in-house and proprietary for proprietary model. What we are building here is an entirely open ecosystem and a horizontal stack that covers everything and invite everybody else to contribute. And from our point of view, our real users, our end users, are all users of vLLM. So that means regardless of anyone, as long as they are using vLLM, deploying vLLM, and need our help within their services and within their hardware, within their model, we are there to serve them and want to help them to make them successful so that we can all together make vLLM the best inference engine in the world.
As we all know, this was the process of company formation here, was a long and interesting journey. And at the point at which you did decide to fundraise, I'd love to learn why you chose to work with Lightspeed. What was it about Lightspeed that appealed to you?
Yeah, great question. Lightspeed has been supporting the lab, Sky Computing Lab, as well as working with the graduate students of our lab over time on different things, right? So in the beginning, it's not even about commercialization at all. James, when we first discussed and talk about, it's not about like how do you actually monetize? Like we didn't even talk about that. It's all about here's an open source project. Here's my users so far. How do I grow the open source project? How do I know who's using it, who's not using it? Why are people not using it? We talk about product, we talk about the market, we talk about the gap between research and the real world. A lot of the conversation really is helpful to graduate students and students working on open source project to really materialize and bridge the gap in their dreams. So this is also why I believe Lightspeed and all the partners together are really there to help to bring technologies to the world, help us to do so. And that's why we chose Lightspeed too.
We feel lucky to be on this journey with you. And on that note, we're here today to talk about a financing round. And obviously with that, unveiling the company. What does all this capital that you're announcing you raised today enable you guys to do?
So the capital we raised today will be used for talent and as well as compute needed for developing the cutting edge method and research around to bring the inference to the next level. Because inference is no longer a single chip activity. Inference no longer runs on there. It runs on a big cluster. It requires constant upkeep, constant maintenance, constant benchmarking, understanding. And then with new model being released, we need a big team to support different kinds of model, different kinds of hardware, and then really go in and deep dive into every single user's custom use cases and workload. I fundamentally believe this world is so vast. There are so many ways to use a model on different chips that we need the capital to enable the entire team to build vLLM to really across the whole world to become the world's best inference engine.
And we talk about inference really shifting kind of in lockstep with the way models are being used and applications are wielding them. Today, obviously, where you hear a lot about these longer horizon agentic tasks. Like, talk to us a little bit about how you think about the way inference is going to change as a result of this new paradigm.
Yeah, so if you look back, inference is just about chats and then completions, so one input, one output. But nowadays, inference is becoming agentic, stateful, and this is where we also see the transition from what I call an inference engine to inference system to inference platform. That means going from a single input-output kind of a system to a complicated distributed system to the entire platform where you not only need abstraction on top of the accelerated computing device as an inference engine, but also state management, environment, and everything you need to enable an agent working like 8 hours, 16 hours, 24 hours, long horizon task. And fundamentally, this cut across the entire model to hardware to sort of the infrastructure co-design. So we need biggest GPU out there, right? We need GPUs that are even more interconnected. We need GPUs that enable us to share multiple models, share multiple inference streams together, and then be able to implement all sorts of optimization to support a long-running state, as well as supporting the complexity of the request.
If the dividing line between training time and test time sort of continues to dissipate somewhat, what does that imply about how inference systems should change?
So inference system will then really becomes a core part of training, first of all, as more rollouts needed for the RL process, as pre-training essentially becoming a known quantity of capital investment, the biggest scaling paradigm on the RL front, on the post-training front, and then finally when you start interacting with the real world, this is when inference absolutely dominates. That's why I've been reading all the news about data center build out and new capacity being added. The way I'm reading it is all of this will become inference compute. The cluster are being built for training, but 6 months later, the cluster will be used entirely for inference. And the new cluster, as they were built, new model will be trained there. Great. But then, you know what? Very soon, inference will start eat up that capacity bits by bits and then be able to really consume all the newly provisioned energy to be able to support all of us today.
Simon, this was awesome. We're so grateful to be your partner and excited to be on this journey with you and your co-founders. Is there anything you want to leave our viewers with? We could talk about hiring. We could talk about anything else we haven't hit on. What should our viewers know that they haven't heard yet about Inferact and the project?
Yeah, so it's really much the co-founder have this vision of building this very technically deep, very interesting system. And fundamentally, we're seeing a paradigm shift. We're seeing a paradigm shift from building vertical system, like model, hardware, just build that for specific model. Like from what I've been hearing before, for example, OpenAI, there's inference engine for Sora, there's another inference engine for new version of Sora, and one inference engine for each model even. But then for us, we're building one inference engine for all the current and future model, for all the current and future hardware, and for all the current and future applications. This is a new operating system. This is a new kinds of database. It's a new kinds of system paradigm and discipline for current and future member of Inferact to work on. And so we're quite excited about the journey ahead and how deep and how technically deep it is and how impactful it can be.
Well said.
Congrats on launching the company today.
Thank you so much.
Let's get back to work.
Yeah, let's go.